Okay, so this is the method I use to measure this copper strip frequency, the resonation frequency of the ferrite, of the copper strip. I put my scope on the both sides of the copper strip. It's the red probe, and I have my function generator in a small coil put in the middle of this coil. My function generator goes to 2 megahertz, but you will see that the resonating coil is strong enough to put the real resonance frequency on my scope. This is so the frequency is 1.883 megahertz at the moment. And you can see that the sine wave I put in a square wave, and the sine wave coming out of the copper strip is something like this, and the frequency is 5.6 at the moment. I can tune a little bit with the fine tune knob of my function generator, but you see this is really the peak. So this is the frequency I put in square wave, and this is what comes out. So my copper strip ferrite is resonating clearly at this 5.6 megahertz at the moment. Another way to look at it is by using my FTT function of the scope. I see the spectrum of the frequency. It's now at 50 megahertz per division, so it's rather clean, but when I go down, I'm now at 3.125 per division, and even more I go to 1.25. I see this big spike coming up, and this is the same frequency, resonance frequency we saw before. I can put this in the middle of the screen. Oops, wrong. What is it? And you can see it is the same 5.7 megahertz. I can zoom in a little bit, 10 times, adjust it, and you see that I have a clear peak, resonance peak, as also seen by the scope on this frequency. I can tune the function generator for the maximum, but it really is here. So I think that my my ferrite yoke is, when it's put complete together, is resonating at this fine 5.7 megahertz, and not the 1 to 2 megahertz frequency I've seen before at the Russian team. So that's what I was seeing, and perhaps somebody else can use this information and see that it's similar or different. Okay, thank you for watching again.